Alright, welcome back. Let's take a look at part C and D. Part C says let g be the function defined by this. Okay, so here we notice that g of x equals the integral from 1 to x, and we're doing this integral in terms of t, so I'm thinking right away the second fundamental theorem of calculus. And the second fundamental theorem of calculus, if you recall, one thing it tells us is that the derivative of this, the derivative of g, is just equal to f of x. Okay, so reading on, it says on the interval from 0 to 4, find all the values which have a relative extremum and determine whether g is a relative max or a relative minimum at each of these values. So if the derivative of g is actually this first line, which is f of x. So let's just take a look at that. You can see that at 0 it equals a negative 1. It is negative. And the derivative of g is equal to 0 at 1. And then to the right of it, it becomes positive. So if we think about this sign chart of g prime, we have a critical point at 1. Moving along at 2, it's equal to 2, so there's no critical point. But then at 3, g prime is equal to 0, so we have another critical point. And let's just examine what's happening to the left and to the right of each one of these values. So this is 1. To the left of it, it's negative, so the function's decreasing. Got a little arrow right there. And then from 1 to 3, it's positive, it's positive. So we have an increasing function. So if the function is decreasing and then turns to increasing, that means that at x equals 1, we have a relative minimum. And the justification for that would be that g prime of x has a sign change from what? From negative to positive. Okay? Alright, let's continue on. We notice that at 3, we have another 0 point. So it's positive to the left, and it's negative to the right. So the function then turns to decreasing, so we have a relative max. So we'll just state that at x equals 3, g prime of x, we have a relative max because the sign changes from positive to negative. Alright, not too bad. And then we're going to look at it and see part D. It says, for the function g, find all the values for which it has a point of inflection. Alright, so this is the second derivative, is the first derivative of f. Alright, so let's see what's happening. Here, the function is concave up because it's positive. We have a 0, so we have a possible point of inflection. But then to the right, it continues its concavity, being concave up. So it does not change concavity here. Okay, at x equals 2, it does not exist, which is a possible point of inflection. So we go from concave up or positive to negative, concave down. So it looks like at x equals 2, we have a point of inflection. So a justification for that, for part D, would just be there's a point of inflection at x equals 2 for g of x because its second derivative does what? Changes sign. That's right. Changes sign from positive to negative. So this problem, you can see, tests your ability to find or to interpret what the derivative means. For the first derivative, it tells us that the function is, whether it's increasing or decreasing, it tells us when we have a relative max or a relative min. And then for part B, we had to sketch it, so we had to use our second derivative for f to see whether it's concave up or concave down. And just recall that it was concave down here, concave up here, another concave down here, and switching back to concave up. And then we have to somehow also show that the derivative does not exist here, so I just drew a cusp. And granted, it was a little sloppy, but using a paper and pencil, I think I could do a little better job. And then in part C, we had to understand what the second fundamental theorem of calculus tells us, that the derivative of a function, when it's defined like this, it is the function itself. So we used that g prime was actually f prime, or excuse me, just f, and then that f prime was g double prime, or the second derivative of g. And then we just interpreted the chart just like we did before. So this is a good problem, and hope you followed along just fine. And we'll see you next time.